Hello and welcome to this session. In this session, we will study about Industrial Internet of Things and Internet of Everything. So, this unit pertains to MIO 002 Smart Technologies. So, in the earlier unit, you had studied about the Internet of Things and you had studied applications regarding the Internet of Things. In that Internet of Things session, there was an application called as Industrial Internet of Things application. So, this IoT not only pertains to the home, smart homes and other kinds of things, however, it has its own application in industries also. The Industrial Internet of Things is the application of IoT in an industrial setting which applies smart technology like smart sensors, actuators and other kinds of equipment, data collection, data storage and cloud based analytics connected together using the internet's infrastructure to achieve value added performance within an industry enterprise. So, for example, IIoT can tell an oil and gas company how to minimize impending damage and disruption before leakage occurs in a gas pipeline. So, earlier in our IoT examples, we had studied about smart agriculture, smart homes and then smart healthcare. So, these were the examples we used to give. But here in the industrial IoT, this particular application pertains to heavy industries and that too like oil, gas company and then construction company, marketing companies. So, these were the companies wherein which you find the applications. So, what is the basic difference or else what is the similarities of IoT and IIoT? IoT is the interconnection of smart devices that monitor, inform and enhance personal aspects of everyday life via the internet. IIoT in a similar way builds on the same technology and concepts as IoT to provide the ability to connect businesses, people, machines, data and devices within an industrial setting specifically targeted to enhance the performance across the manufacturing value chain. The basic similarities of IoT and IIoT are both have the same fundamental layer, that is the IoT layer, on top of which they were built. With IIoT being a subset of the large of IoT, they automatically share common technologies like sensors, cloud platforms, connectivity and analytics, which are the four basic building pillars for the IoT applications. Another similarity constitutes the domains for which their application is designed, as well as the standards and regulations. Another similarity constitutes the domains for which their application is designed, as well as the standards and regulations they have to conform to in order for them to be successful and commercially available. So, after talking about the IoT similarities of IoT and IIoT, this is the figure which shows the similarities between industrial and consumer, or else which shows the differences also here. You can see in the industrial internet of things, there are heavy machinery, transportation and other kinds of things used, the automation, factories, healthcare and others are the applications for the industrial IoT. And for the consumer IoT, you can see the wearables, the phones, the smart TVs, appliances, home monitoring, home automation. So, these were actually the IoT applications which we commonly speak about. And here you can take a note that IIoT is the subset of the whole IoT. So, what exactly is the definition that we can give for the IIoT? The IIoT consists of interconnected machinery and the advanced analytics platforms that process the data that they produce. IIoT devices range from tiny environmental sensors to complex industrial robots. So, while the word industrial may call to mind warehouses, shipyards and factory floors, IIoT technologies holds a lot of promise for a diverse range of industries including agriculture, healthcare, financial services, retail and advertising. So there are several applications we can talk about IIoT in very much diverse industries. It doesn't pertain to only one particular industry or the manufacturing company, but it has its applications in wide variety of diverse industries. Like if you take the case of production, so this is the industry in which most IIoT technology is currently being implemented. IIoT enabled machines can self-monitor and predict potential problems, meaningless downtime and greater overall efficiency. And if you take the case of the supply chain management or supply chain management company, with sensor managed inventory, IIoT technology could take care of ordering supplies just before they go out of stock. This decreases the amount of waste produced while keeping necessary goods in stock and frees up employees to focus on other tasks. In the building management also, it has its own application, that is IIoT technology could make building management simpler and more secure. With sensor driven climate control, the guesswork and frustration involved in manually changing a building's climate will be eliminated totally. Additionally, devices that monitor entry points in the building and respond to potential threats quickly will increase the building's security. In the healthcare, with these devices that monitor patients remotely and notify healthcare providers as soon as patient status change, IIoT could cause healthcare to become more precise and responsive. Eventually, artificial intelligence may even be able to take care of these patient diagnoses, meaning doctors are able to treat them sooner and more effectively. In the retail also, it has its advantage. In the IIoT technology has the potential to make quick, intelligent marketing decisions for individual stores with storefronts that automatically update based on consumer interest and the ability to put together smart promotions. Retail outlets that maintain IIoT technology could gain a significant advantage over their competitors. So basically the IIoT applications, you can summarize them as smart factories, supply chain and inventory organizations, data analytics, smart buildings, condition monitoring, asset performance system, manufacturing executive systems. Earlier we were only limited to MIS, but here in the with the use of these IIoT devices and others, we can have the manufacturing execution information or its manufacturing execution systems. So what exactly are the enabling technologies to use the IIoT? The IIoT is basically the backbone for IIoT applications is the internet. Other than this, the enabling technologies are, one is the Internet of Things, which we had like listened in the first session, and then big data, cloud computing, edge computing, cyber security, artificial intelligence and machine learning, mobile technologies, machine to machine communication, advanced robotics, radio frequency identification technology, cognitive computing. So these are some of the IIoT enabling technologies. So when you compare this IIoT a little bit in a depth, so the basic differences that you can find are, the IIoT focuses on industrial applications such as manufacturing, power plants, oil, gas, manufacturing, retail and other kinds of industries. But IoT focuses on general applications ranging from wearables to robots and machines. IIoT uses critical equipment and devices connected over a network, which will cause a life-threatening or other emergency situations on failure, therefore uses more sensitive and precise sensors. But in case of IoT, its implementation starts with small scale level, so there is no need to worry about life-threatening situations. IIoT deals with large scale networks, whereas IoT deals with small scale networks. IIoT can be programmed remotely and offers remote on-site programming, but IoT offers easy off-site programming. IIoT handles data ranging from medium to high. IoT handles very high volume of data. IIoT requires robust security to protect the data, but whereas IoT requires identity and privacy kind of security. IoT needs stringent requirements, whereas IoT needs moderate kind of requirements. IoT have a very long life cycle for the development of applications, but IoT may be having a simple and short product life cycle. IoT has high reliability, and IoT are very less reliable devices. So coming to the benefits of Industrial Internet of Things, it has increased efficiency. So the biggest benefit of IIoT is to give manufacturers the ability to automate and optimize their workflows. Robotics and automated machinery work more efficiently and accurately, helping manufacturers streamline end-to-end operations. The second benefit that we will be getting through this IIoT is the real-time visibility through a asset tracking. Asset tracking monitors crucial data and information on the status, condition and location of assets. Through the asset tracking software, organizations can improve asset utilization, visibility, planning and maintenance. So another essential benefit that the IIoT provides is the predictive maintenance. According to analyst firm Aberdeen Research, 82% of companies have experienced unplanned downtime over the past 3 years, following high costs of as much as $260,000 an hour. Thanks to the IIoT's predictive maintenance ability, businesses can make an intervention before the damage is done. Coming to the optimal planning and inventory management, today global supply chains are struggling to meet customer demand and even growing competition. One of the solutions is inventory optimization. Businesses can monitor the location of the assets, their condition and other factors through sensors, decrease costs, manual work and preventing damages. Knowing exact and real-time data on assets means decreasing costs, manual work and preventing the damages. Another benefit that we can talk about is the save time and reduce costs. All the data-driven insights rely upon IIoT to bring value, optimize operations, create new products or services and design better business models. So coming to the technologies, IIoT, in the earlier session we had seen the IIoT technologies and the protocols. Here also we can see some IIoT networks and protocols, where in which the first important network that we can talk about is the Wi-Fi technology. As internet is the backbone for these particular applications, Wi-Fi is the way, the wireless networking technology. This has become very familiar to most of us since it became the standard method for connecting PCs, smartphones and tablets to the internet. It is a derivative of the established wired Ethernet network and is based on the IEEE 802.11 wireless standard. The other technology that we can talk about which is used in the IIoT is the Zigbee 3.0. It is a lower power network widely used in industrial and factory settings. The related protocol, dot protocol, was created by the same team, and this has become an internationally accepted universal method of secure connection between different Internet of Things devices. The third technology that we can talk about is the LoRaWAN, that is low range wide area network. This device provides two-way secure connections across various large networks. And then the other technology which is very much popular is the Bluetooth technology. Also it is widely used in consumer technology. Bluetooth is a short range connection standard based on the use of ultra high frequency radio waves. The other technology is the Sigfox. It has been developed in France. Sigfox connects low power always on objects like electricity meters and smartwatches, which allows them to continuously exchange small quantities of data. And there are certain protocols which are very much essential for the IIoT applications. The first protocol that we can talk about is the MQTT. MQTT stands for Message Queue Telemetry Transport. This is a lightweight, low power protocol used to transmit simple data sets between sensors and applications. It sits on the top of the standard internet networking system TCP/IP. And the second technology is the AMQP technique, that is Advanced Message Queuing Protocol. This is an international standard focused on the transmission of messages between devices. It is approved as an international standard. And then another protocol is the OPC Unified Architecture. In short, we can call it as OPC UA. It is an open machine-to-machine communication protocol supporting cross-platform industrial automation, data sharing and robust interoperability of the systems. And then coming to the digital twin, there is a term which is very much popular along with these IIoT applications, that is the digital twin. A digital twin is a virtual replica of a physical product or process or a system. It is a digital representation or a digital instantiation that includes the virtual model of the physical object, data from the object, a unique one-to-one correspondence to the object and the ability to monitor the object. So, this particular data twin is a pairing of the virtual and physical worlds, allows analysis of data and monitoring of the systems to mitigate problems before they even occur, prevent downtime, develop new opportunities and even plan by using simulations. It does so by using sensors to collect real-time data about a physical item. One of the first users of digital twins was NASA, which was been using this concept successfully to emulate space flights on the ground. There is another technology we have to talk about, that is the electronic logging device. In short, we can call it as the ELD. So, onboard sensors that monitor speed, driving time and how often individual drivers use their brakes, helping to conserve fuel, improve driver safety and reduce idle resources. If the driver makes a dangerous maneuver or is at the wheel for too long, the driver is alerted and the dispatcher is notified. This technology can replace the paper logs that drivers were once required to fill out every day. Other technology that is very much popular with the IIoT applications is the RFID technology, a system that involves tags and readers like a smarter version of barcode technology. Readers identify RFID tags using radio waves, meaning the tags can be read by multiple readers at once and over a longer distance than traditional UPSCs. RFID tags make it possible to easily track and monitor the things on which they are attached. Coming to, there is a hype about the 5G. So currently most of the metros we are using the 5G internet. So what exactly is the relation between the 5G and IIoT? 5G is the emerging standard for mobile networks. It has been specifically designed to deliver fast data throughput speeds with low latency. So 5G will support download speeds of up to 2 Gbps with sub-millisecond latency. So the emergence of 5G will likely affect the use of IIoT devices in two main ways. First is 5G's high throughput and low latency will make it possible for devices to share data in real time. This real-time connectivity will support use cases such as driverless cars and smart cities. Secondly, it will likely result in device proliferation. Industrial operations might use thousands of 5G connected devices, and 5G's high speed and low latency also means we will be likely see IIoT devices used in remote sites whose lack of high speed connectivity previously made IIoT use impractical. Let us concentrate on IIoT work. In the earlier, we had seen about the technologies, we had seen about the networks, we had seen about the protocols. So, how these particular things are being glued and an IIoT application will be developed. An IIoT network consists of multiple sensors connected via various wireless protocols in order to exchange data with the cloud and with each other. The basic structure of an IIoT network is as follows. The sensor equipped devices and hardware each connected to the local network. The local network itself each is connected to the cloud or internet in turn. Cloud connected servers will receive and process the continuous stream of data from your devices. For example, operating temperature, it may be vibration and power consumption. This little data consolidates over time into large quantities which can be analyzed for deep insights into your operations. This is the figure which talks about the 3-tier IIoT system architecture. One tier is the edge tier, the middle tier is the platform tier, and the third tier is the enterprise tier. In the edge tier collects data from the edge nodes using the proximity network. The architectural characteristics of this tier includes the breadth of distribution, location, governance scope, and the nature of proximity network vary depending on the specific use cases. Coming to the middle tier, that is the platform tier. The platform tier receives, processes and forwards control commands from the enterprise tier to the edge tier. It consolidates, processes and analyzes data flows from the edge tier to the other tiers. It provides management functions for devices and assets. It also offers non-domain specific services such as data query and analytics. In the enterprise tier, that implements domain-specific applications, decision support systems, and provides interfaces to end users, including operations specialists. The enterprise tier receives data flows from the edge and the middle tier, that is the platform tier. It also issues control commands to the platform tier and edge tier. The proximity network connects sensors, actuators, devices, control systems, and assets, collectively called as the edge nodes. It typically connects these edge nodes as one or more clusters related to a gateway that bridges to the other networks. The access network enables the connectivity for data and control flows between the edge and the platform tiers. It may be a corporate network or an overlay private network over the public internet or a 4G or 5G network. In the service network, it is nothing but it enables connectivity between the services in the platform tier and the enterprise tier and the services within each tier. It may be an overlay private network over the public internet or the internet itself, allowing the enterprise grade of security between end users and various services. We had seen several applications of IIoT in the previous slides. However, in the IIoT, coming to the IIoT business cases, it helps the aerospace. That is one of the business case that can be visualized using the IIoT. In airports, airplanes, drones and other unmanned air vehicles, this IIoT can be applied. And the second sector which can have the business case is the agriculture sector. The connected farms, livestock, machines, vehicles which are used in the agricultural fields and other processes. And the automotive, that is the connected semi-autonomous or autonomous vehicles, is the third business case that we can visualize. In the energy sector also they have the IIoT applications, that is the smart grid, energy resources and renewable energy. In the healthcare, it finds its own use cases like the connected healthcare, robotic surgery and medical imaging. In the military also it finds IIoT applications like the military vehicles, simulations, training and operations. Smart cities, that is the primary application of the IIoT, citizen and municipal services, parking, infrastructure and other kinds of management. And then coming to the transportation and logistics, it has the use cases, the buses, connected buses, subways, trains, the hyperloop that we are we are talking about, wherein which the experiments are going on. So these are some of the use cases wherein which in the business field we can visualize. So IIoT, as other technology, it also has certain key challenges in its implementation. First key challenge is its interoperability, because it has to connect with various devices, and that too there is no physical standards as on present. However, it works on different in the IIoT application, it has various devices to be connected like the sensors, actuators, cloud and other kinds of things. So interoperability is the big challenge. And then the next one is the device reliability, because in the industry there may be some harsh conditions wherein which the devices are being kept at high temperatures. The environment may not be that much favorable to the device to work. So device reliability is one of the key challenge in implementing the IIoT. The other feature is the security feature, because all the devices are kept apart, all the IIoT devices are kept apart, and they may be on the run also on the roads or else on the like inside the factory premises or company premises, where in which the security, either it may be physical security or else virtual security, this or else attacks that are coming from the cyber. So these are some of the things that we have to completely concentrate whenever we are designing the IIoT applications. Network performance is another issue. Mostly we use the network technologies that we had talked about, like the Zigbee technology, Wi-Fi, Bluetooth, so and then low range technologies and other kinds of things. So network performance is once again a kind of key challenge to implement the IIoT. Maintenance and management of everything. So for each and every device there may be some patches coming in, or else some sort of updates are required. So once again the maintenance and the management of everything is also a big challenge. Coming to the second aspect, that is the Internet of Everything. So till now we are talking about the Internet of Things, but here the Internet of Everything was listed as one of the top trends in 2015 by Gartner. This may prevail for several decades in future. IOE is the short form for Internet of Everything. IOE is the intelligent connection of people, process, data and things. You can see here we are not at all talking, we are not only talking about the process, data and things, we are including the people also. So this particular Internet of Everything includes the people, process, data and things. The Internet of Everything, the definition given by Cisco in 2013 is bringing together people, process, data and things to make networked connections more relevant and valuable than ever before, turning information into actions that create new capabilities, richer experiences and unprecedented economic opportunity for businesses, individuals and countries. So this was the definition given by Cisco in 2013. So the basic pillars of IOE are: one is people, connecting people in more relevant, valuable ways. Data is the second pillar, converting data into intelligence to make better decisions. Process is the third pillar, delivering the right information to the right person or machine at the right time. Things is the fourth pillar, physical devices and objects connected to the internet and each other for intelligent decision making, often called Internet of Things. Coming to the application part, saving lives by connecting roads and hospitals is one of the applications that can be visualized using the IOE application. Supply chain management, elderly care, connecting homes for a comfortable life, agriculture, smart cities, businesses. Here the basic aspect or else the variation from its predecessors, that is IoT and IIoT, is here the people also include into that particular as the fourth pillar to the applications. So here in this particular session we had talked about the IIoT, its applications, use cases, and then how these particular IIoT applications work, what are the various technologies, protocols, and we towards the end we had talked about the key challenges of IIoT, and then we had given a little bit focus about the Internet of Everything. Hope you had understood this particular session. However, for more details you can read the course material provided to you as the part of unit 2 of your course. Thank you. Thanks for your attention.